With our calculate balance function implemented, we've completed the final step in creating a respectable cryptocurrency. Users have wallets and conduct transactions with each other. And as blocks of those transactions are added to the blockchain, users will recalculate their wallet balances based on the history of transactions. The function is pretty powerful, so let's ensure that it works properly by adding a new scenario to the tests for our wallet class. In this test, right at the bottom of the wallet/index.test.js file, we'll describe a new scenario where we're calculating a balance. Then we have our callback arrow function as the second parameter. To test that the calculate balance function adds up all the outputs that a wallet receives, we'll conduct a few transactions and then store them on the blockchain. We'll check that as a result of those transactions on the chain, the recipient's wallet balance adds up all the output that it receives. Likewise, the sender's wallet should be equal to all of the currency that it has left over after it exchanged all of its currency away. To do this, let's start by defining an add balance variable, which will define how much currency we're exchanging in each transaction. Likewise, we'll repeat the transaction a few times, so we'll define a repeat add variable. And finally, we'll have a new wallet, which will be tasked with sending the transactions, so we'll call this the sender wallet. And now before each following test, we'll make a new sender wallet, and then we'll also set the add balance and repeat add variables to arbitrary values. First up, let's construct the new sender wallet by creating a new wallet instance from the wallet class. The add balance and repeat add values are arbitrary, so how about an add balance of 100 and then a repeat add of 3, just as long as add balance times repeat add isn't over the initial balance of each wallet, which is 500. And now the sender wallet will be used to send the balance that we specified with the add balance variable according to the number that we set with the repeat add variable. So we'll repeat this transaction repeat add times with the for loop that goes from I as long as I is less than the repeat add starting from 0 I++. And then we'll call senderWallet.createTransaction. The first parameter is the recipient. Now, we don't have a recipient variable, but we do have the original wallet instance to use. So we can use the wallet.public key since the wallet is available to every test in this file. The amount is the add balance to send away, and the repeat add, or rather, the third parameter is the blockchain instance. And then the last parameter is the transaction pool that the transaction from the wallet will be added to. The idea is to calculate the balance after the series of transactions has been added to the chain. So in order for the calculate balance function to work, it needs a blockchain consisting of these transactions. So let's create a block that consists of the transactions in the transactions pool that has all of these transactions loaded in to the blockchain. Great. This allows us to now write our first test, which will make sure that it calculates the balance for the recipient. So the message says it calculates the balance for blockchain transactions matching the recipient. The recipient in this case is the original wallet. So we'll expect that if we call wallet.calculateBalance and then we load in the blockchain instance, this should equal the initial balance of all wallets, which is this global variable, plus the add balance times the repeat add, which is how many times, or rather how much currency the wallet received from these transactions. Notice that we have a dependency on the initial balance variable, which we'll require in just a moment. But first, let's also calculate the balance for blockchain transactions that match the sender. And this test will look pretty much identical to the previous one, except there's an important difference. So as we calculate the balance for the sender wallet by using its calculate balance function with the same blockchain instance, This should again equal the initial balance minus the add balance times repeat add, which should represent how much currency they sent away. So with these two tests, we should be able to show that the calculate balance function shows the proper balance based off of a blockchain of transactions. Now we do have this dependency on initial balance, so let's require it at the top of the file by grabbing it from the object that's exported from the configuration file. And with that, we're ready to run our tests and make sure this calculate balance function is working as intended. Let's go ahead and open up the command line and then run npm run test. As we do so, the tests are going. Looks like everything is passing so far, and indeed, we get a fully passing test suite, which shows that our calculate balance function indeed adds up all the outputs that belong to a wallet. Still, our calculate balance function is a little more powerful than these tests can show. Really, it only adds up the outputs for a wallet since that wallet's most recent transaction. So let's create an inner scenario that proves that the balance is only calculated since a recent transaction for a wallet. In this case, we'll make that recipient wallet conduct a transaction now. And then we'll let it receive a new output from the original sender. In this case, calculating the balance shouldn't add up all of the outputs, but only the outputs since the recipient made his or her transaction, and the output that the recipient received after that transaction as well. So let's describe an inner scenario now within the test, right at the bottom where we're calculating a balance. So after our couple of unit tests, let's describe a situation where the recipient now conducts a transaction. And the recipient conducts a transaction. Let's now define a subtract balance variable as well as recipient balance variable, which will track however much the recipient is sending away with subtract balance, and then recipient balance will be a variable to track the recipient's current balance. And now before each following test in this scenario, we'll conduct a new transaction from the recipient's wallet. The goal will be to add a fresh set of transactions to the blockchain that consists solely of the new recipient transaction. So we're going to have to clear the pool first by calling tp.clear, so that way the old transactions aren't there. Next, let's set the subtract balance variable to an arbitrary amount, so how about 60? And then the recipient is the current balance of the recipient wallet, which is the regular wallet object. And then we'll calculate the balance by using the current blockchain. Now we're prepared to create a new transaction by calling wallet.createTransaction. So this is the recipient wallet now conducting a transaction. Let's send some currency to the sender wallet's public key. Sender wallet.public key is the first parameter of the amount of subtract balance. The third parameter is the blockchain, and the last parameter is the transaction pool instance. Perfect. Finally, we add a block to the blockchain consisting of the transactions that are in the transaction pool, which would be this one new transaction we just created. All right, and now the recipient has created a recent transaction. So if they receive a new transaction, the calculate balance function should now only add up currency since this recent transaction, and then including any outputs they receive after that. So let's check that by describing a new situation where the sender sends another transaction to the recipient. And in this, we'll have a before each block, which allows us to run code before each following test. Again, we're going to want to clear the transaction pool, so that way we can create a fresh set of transactions. And in this case, we'll use the sender wallet to create another transaction using the wallet.public key as the recipient. So again, the wallet is the recipient once more. We'll use the add balance amount. We'll load in the blockchain instance. And then the last parameter is the transaction pool to add the transaction to. And finally, we can add a new block that consists of the transactions within the transaction pool. Excellent. Now in this case, we're going to have a test that calculates the recipient balance. The test says it calculates the recipient balance, but only using transactions since its most recent one. In other words, it only calculates its own balance using transactions since its most recent transaction itself. For this test, we'll calculate the balance with the original recipient wallet on top of the blockchain. And then this should equal this recipient balance that we calculated over here for the wallet minus the subtract balance that they sent away. So let's subtract the subtract balance that they should have exchanged away. We'll also add the add balance that they received from the most recent transaction from the sender wallet. Great. With that file saved, the command line test runner should have rerun, so go ahead and open up the command line. And what we should find is that indeed all the tests are passing, and to rerun it and check it out explicitly, we can press A in the command line runner to see overall if all the tests pass. It's taking around 11 seconds because there's quite a few blocks to mine, which all take quite a bit of time, but indeed all the tests pass. Great. That confirms that the balance calculation works properly and only considers output amounts since a user's most recent transaction. With the calculate balance function completed, we have a fully created cryptocurrency. Nice. Users have wallets and can conduct transactions with each other. Moreover, miners do the work of adding those transactions to the blockchain. And then based off of the blockchain history, wallets recalculate their balance. The test suite is also pretty reassuring that the functionality works as expected. But perhaps an even more convincing and fun way to test and explore this working cryptocurrency application would be to spin up a couple instances of the app and see the full project in action. So let's get to that next.